Okay, angles and parallel lines. We should all be able to recognise what parallel lines are. Two lines that don't meet, and the arrows that's on them will signify that they are parallel lines. Don't assume they're parallel lines. It'll show you, certainly on an examination paper, that they are actually parallel. Now a line that cuts right across them, like that, that's called a transversal. Now it's indicating some angles on the top of each parallel line. Now there's special properties that we need to learn about parallel lines. Now it's always noticeable that when you're actually drawing this, or you're looking at it on an exam paper, that you won't necessarily have protractors to measure to understand that they are actually equal. But if we actually look, if we actually measure them, and this one's going in a clockwise direction, and we can see it's 140 degrees. So anywhere on that line, on that transversal, any angle on the outside here will always be 140 degrees if it's on top of the parallel line. Now the line that's underneath it, the angle that's underneath it, it's directly opposite or vertically opposite. Angles vertically opposite are also equal. So that's 140 degrees. Vertically opposite will also be 140 degrees. Now, angles on a straight line is what we've got here. Ignore everything else that's around it. But angles on a straight line, that's 140. What will that one be? What should angles on a straight line add up to? All angles on a straight line, 180 degrees. So if that's 140 degrees, 40 degrees. And again, what you'll notice on this opposite side, if that's 140 degrees on the left hand side of the transversal, then on the opposite side, all the way and throughout, will be 40 degrees. And again, opposite angles are also equal. And what you should notice, that everything around there is mirrored up here. And if you add them all up together, it'll equal 360 degrees. Another thing to notice, we're actually keeping the same degrees, angles. Now, that angle's 40 degrees, and on the opposite side, round here, that's also 40 degrees. Now it's on the opposite side of the transversal, and we can actually, it says up top here, alternate angles. They're alternate because they're on different sides of the transversal. One's on one side, and it's on the other, so it's alternating sides. And we can actually, it said Z angles, we can actually sort of, if I can trace over a Z. So it's a Z angle. Now Z angles will be equal. Now there'll also be one on the other side as well. Going that way. Okay? Z angle going that way. Again, alternate. 140 degrees and alternate on that side. Corresponding angles. Now, we call these F angles. I'm just tracing the F. So it's underneath the actual parallel line, and they are also equal. Again, underneath the parallel line, also equal 40 degrees. Okay, so I'll calculate the missing angles X. We've got 60 degrees, and it's inside the parallel line, and it's on the opposite side. We've got another angle. So what is that going to equal? It's on the opposite side of the transversal. They're going to be equal because they are alternate angles or Z angles. I'll look at the next one. If you want to, you can actually turn it around so it's actually facing the same way as that. Turn it all around completely so the angles are facing directly in front of you, just like this one is here. But that's on the underside of the parallel line. On the underside, what sort of letter does it draw? I think there's an F going on here. So they're corresponding angles. If that's 130 degrees, I'm guessing that's going to be 130 degrees as well. And it's right. Okay, just have to pause the video and have a look at the rest of them. How did you do? What's really important with angles in parallel lines is not just being able to say what the angle is, but use the correct vocabulary. So corresponding, alternate, Z angles or F angles. That's very important.